Okay, so this is chapter 1 lecture, which is chemistry, and the first section is just general chemistry, and this is the one I'm going to skip. You guys need to know the definitions. You should know them already. And you know how we go about doing the symbols. Now on this one right here, I want to point out the elements that are most common in life. Now, I memorized this with the acronym SCHNOPS. It's just what was taught to me, and it's easy to remember. It's not an exact order listed up there, okay? But carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. There's also a couple trace elements that are really, really small amounts. But that's the elements of life right there. And you guys want to remember those. Actually, let me back up and say one more thing about it. A lot of times people think that life is built of water. You saw there was hydrogen and oxygen in there. Life is not built of water. Life is full of water. We are built of carbon molecules, okay? But there's water in the cells. It's kind of like this building is mostly what? Well, according to my analogy that we're mostly water, it'd be mostly air. That's not what this building is, right, you guys? Okay, so see the difference? So we're not built of water, okay? Okay, this one again, I expect you guys to know the atomic particles. And then very important about those electrons, right? And where they're found, the electron shells or the clouds or the orbitals. But the electrons are important because that's going to give the atoms their properties. And we're built of atoms. Okay, so that's going to give the molecules of life their properties. Real quick with carbon there. Carbon likes to bond to 4 things. Makes it extremely versatile. It can bond to 4 different things. It can bond to make chains. It can make rings. Okay, a little bit there more with nitrogen and oxygen. And then again, back to just that atomic structure, you guys should know that protons is also, we represent that the atomic number, right? Same number of neutrons as protons are found in the what? Nucleus. Normally the same number of protons is the number of electrons, right? Orbiting. Okay, that's a typical situation for an atom. However, there are isotopes, and isotopes are not in that normal atomic balance. They have a different number of what? Neutrons, okay? It makes them unstable, and some of them are radioactive, and their nucleus actually is going to lose particles because it's not stable. And that gives us some cool stuff that we can use as tools in biology, like carbon dating. Okay, again, you guys should be well aware of chemical reactions. But then, remember, we're based on chemistry, okay, like everything. And so that's the coolness with life is just using chemistry to exist. So all the reactions that go on in all the cells are what powers life, what builds life. Okay, so we have to know some basic chemistry. So chemical reactions occur in the cells. Remember, the cells are the basic unit of life. Now, why are they so important? Number 1, they're the only way to form new molecules. Okay, so we're made of those carbon molecules. We also need special enzymes. We need all those proteins. So reactions have to happen in cells just for building life, growth, development, but replacement as well, fixing things. And then for energy. Okay, so we use chemical energy, and the chemical energy is available through reactions. Okay, you guys should be well aware of chemical reactions and how they're represented through equations. And so,
Water's reaction.
sorry. So check that.
The law of conservation of matter states that matter is neither created nor destroyed in chemical reactions. When two molecules of water receive enough energy to start a chemical reaction called the activation energy, two molecules of hydrogen and one molecule of oxygen are produced. Note that the number of hydrogen and oxygen atoms remain the same before and after the reaction.
How am I doing on time, you guys? On your watches? Oh, good. Okay. So then this leads us to law of conservation of matter, which you guys should be very familiar with. Sorry about that. And again, those reactions are balanced because new atoms just don't pop up. Atoms don't just disappear. Why is it louder? Oh, because I turned it up. A little bit different than the conservation of energy. We're not going to talk really about it right now, but just since I'm mentioning it, just so you get them straight in your head. Same thing, right? Energy cannot be created or destroyed. However, conservation of mass is a cycle, and energy is a one-way. We're getting energy constantly replenished from the sun to us, for example. But in the whole universe, you could say energy is a cycle again, but to us it's a little bit different. Okay, activation energy. You might have forgotten this in the past, but this is just the amount of energy to just start a reaction going. All reactions need a teeny bit to a large amount of energy to occur, and you will see this through some graphs. Okay, then we got to bonding. You guys remember the two main bonds that we talk about? Ionic and, hold on, actually we'll get to it in a second. First with ionic, remember now we're making ions basically here, and the atoms are donating or taking. They have to be very close together. They dissolve easily in water, but they are strong bonds, like crystalline bonds. Then we get to the covalent bonds. And this one, you have to remember, the electrons are doing what? They're sharing them. Okay? So these bonds aren't quite as strong as the ionic bonds, but these are the bonds, again, of life. Okay? Are the covalent bonds. And then we're going to get to making some molecules, but I think I'm kind of out of time.